into this computer. Okay, so here we go. I'm going to go ahead and share my screen, and this is going to be, let's see, going straight to video physics. So let me show you what I'm going to do. You know how we collected data, and in some instances we collected data. We started off with 50, a pulse width modulation of a raw count of 50, and we're coming up with something like this. So I can just show you real quick, the kind of data that I'm just coming up with. And of course I have 60, yeah, I can keep going on and on and on with that, 60, 70, 80, and 90. And this one looks nice and tight. Okay, and so I have 50, 60, 70, 80, 90. So I'm going to use those I'm going to find the descriptive statistics of those and then use those to actually create a regression analysis. All right. And once the regression analysis is done, I want to use 55, 65, 75, 95, 105, 110, 100, 110, and 85 to actually verify those things. Okay. So what I'm going to do is I'm going to go ahead and start with 50. I'm going to show you how how this is done with one example, and then this will give you an explanation as to how to do it for all the other ones. So I'm just going to go ahead and go directly to my share button here, say data file, and then I want to choose open in. So once I choose open in, I am going to go over to graphical. So you'll see graphical. This is a free program. It accompanies this particular application, video physics. So I'm going to go ahead and select on graphical. With graphical, you'll see that all of the data is here. And I really want this X and Y, I want these to be in Microsoft Excel. So the way you're going to do that is by taking the share button again, and I'm going to take data, and I want my data to be opened in. And that's going to be Microsoft Excel. So I just need to find it. There we go. Microsoft Excel. So let's copy it to Microsoft Excel. All right. So right now I need to save a copy. So I'm going to save a copy, and it might be prudent to save it to your OneDrive. And so I could do that, or you could save it to Dropbox. For some reason, I'm just going to save it to OneDrive. So I'm going to go all the way down to OneDrive, and I should be able to create a folder down here. Now you can see I have Dropbox right here, so I could save it to Dropbox as well. But I'm going to go ahead and save it to, I'm going to create a folder, and I'm going to call this PWM and Angular Velocity. All right. So I'm just going to go ahead and save that there. And what you'll see is the yellow strip is going to go away. Now, the first thing that I like to do is I like to open up all of my columns so I can see exactly what we have here. So we have time, we have our X in centimeters, we have our Y in centimeters, we have our X velocity in centimeters, and our Y velocity in centimeters. Okay, so some of the first things that we want to do is we want to convert this over to meters, and that's what I'm going to do. So I'm going to say X meters. I'm going to go ahead and do Y in meters. I'm going to do Vx in meters per second. So know that velocity is measured in, oh, I didn't do that. Let's see. It should be Vx, and then I'll do Vy the same way. All right. So I'm going to say equals to, and I'm going to go all the way over here to my X in centimeters. So there are 100 centimeters per meter. So I'm just going to go ahead and do select B2, and then we want to divide this by 100. All right, so now we can see that this is 1.79 meters. What? Is that right? This must have been in millimeters. Let me just double check. Check my origin and my scale. Nope. See, I have this in 49.5 centimeters. It's actually millimeters. So let me just go ahead and take that. And I'm just going to do the data file again. I'm going to go ahead and open in. I'm doing this on purpose because later on I'll forget what happened, and I don't want to do that. I mean, I want to have evidence. I want to know what I'm doing here. So I'm going to go ahead and save this to, or copy it to Microsoft Excel. And I'm going to save a copy just like I did before. And I'll put it into the same folder here. And I'm just going to save it. And I'll work from this particular document. So I know that this is in millimeters, as we can see. So we see I have time, we have X in millimeters, we have Y in millimeters, and all of those things. And you see how I just changed one thing in video physics, and then all the other ones pretty much, I mean, the data just changed for me. So I'm like, wow, that's cool. So let me go ahead and open each one of these. So this is not going to be millimeters. This is going to be meters. Okay, I'm just changing those around. All I'm doing is just tapping on the inside of them. So now we have velocity, this X position, Y position, all of these things are going to be in meters. So I'm going to go ahead and say equals to 179.28 millimeters. And I'm going to just divide this by 1,000. So I have that, and fill this to the right and see how that'll work out. That work out. So yep, it's working out for all of those. And since I have, let me see how many data points. I have a whole bunch of data points. Okay, I have like 1,300, almost 1,400 data points on here. So what I'm going to do is I'm going to take all three of these, well, all four of these, and I just want to fill down. So all I have to do is grab the fill handle and then throw down. Now, you can do the same stuff on your computer, okay? So now that we have all of this in meters, I can go ahead and just hide this extra stuff. I don't really need it. So I'm just gonna hide it, not delete it. And I'll go ahead and wrap this and middle and center it. So make it like so, be a little bit smaller, and we can still see everything, okay? So we're looking for angular velocity. This has a raw count of 50, and I do have a picture that's associated with this, and I want to make sure that I put the time that's associated with this in here. And so let me go, and you guys have access to this document as well. So I'm going to go all the way back. It's 183 pages. So I have 50, and if you look here, I have 400 microseconds for 50, all right? So I'm just gonna put that in there, 400 microseconds. Nah, I'll just go back to Microsoft Excel and say, I'll just insert something on the top here and say the pulse width. Basically is 400. Microseconds. And this also is at a raw count of, I'll just put raw count is 50 and close that. So I can go ahead and merge these. So that's just letting you know what's happening there, that this is what we're looking at. And I need this, I believe that we need this so that we can properly graph everything. So, you know, when I'm on this iPad, and so I could do everything that I've been doing before, and that's like finding the statistics. Descriptive statistics of the, no, not yet. Not quite there yet. We're jumping ahead. So we're looking for angular velocity. So we need to find the radius first. So the radius is also going to be in meters. And if you guys remember, and I'll just put the tangential velocity right next to it. This is going to be in meters per second. So we have tangential in our radius here. So what I want to do is I'm going to go ahead and use Pythagorean's theorem. That's the square root to find the radius. Square root of, I like power. Square root of the power of x. I'm just going to make this squared. And this is going to be plus power of y squared. All right, now close that. So that's my radius. Okay, makes some sense. And then the tangential velocity is going to be something very similar. I'm just going to say equals to SQRT. I'm just going to select on that. And I'm going to choose power again and choose my x velocity and square that. And then I am going to add the y velocity squared to this value and then take the square root of it. So now we have these three things taking place. Hey, Dane, what's going on?
Can you please help me?
Yeah, what you need help with? Let me just do this real quick. Give me like a couple minutes.
All right.
So now let's just go ahead and do angular velocity as well. And this is going to be in rads per second. All right, radians per second. And the angular velocity is just going to be equal to tangential divided by the radius. Okay, so I'm going to go ahead and select these three. And because we know this is like 1,400 data points, I am just going to throw this down and it should take all of my data points down. So we have the angular velocity and all of this stuff. But what I'm going to do in the next video, I'm going to take this to the desktop and I want to do my statistics. And then we want to collect, well, just do my statistics on this. So I've got to rename this and call this 50. Just say done. All righty.